Okay, you know what's crazy is when I went to look for the 5010 motor on GrabCAD to use as a reference, the motor as a reference, I found this design by this guy right here and this guy right here, inspired by Paul. Wait, this is inspired by this guy. Oh, I see. Huh, what is this? Oh wow, this looks pretty nice. For a mirrored, okay. Let's see how this one works. Okay, this is pretty interesting actually. Oh wow, this is okay. So instead of two discs, they have three discs. One disc is, I guess, assuming the same mass as both of these combined. I'm not sure why they have a smaller one on the inside. That's a pretty interesting design. Anyways, so I'm gonna go ahead and take a look at this. So I see there's four discs, which is kind of like what the other guy did, but these two are just merged together. I feel like this is pretty, I don't know, I feel like it might be a little bit unnecessary. It makes everything a little bit more bulky than it needs to be. I actually do like this base design, although I feel like actually, yeah, I do like this base design. And this is exactly what I was thinking with the encoder putting on the inside of the cycloidal. Because if we got rid of these two, and I feel like, okay, let's see here. So this bearing right here is a pretty large bearing. Okay, this bearing is literally bigger than the motor itself. Huh, okay. I feel like we could definitely cut some complex. I feel like this is overcomplicated. Oh my goodness, look at this madness. Okay, so we have two giant bearings. These are 7 millimeters thick, I believe, right? 7 millimeters thick, which already adds 14 millimeters. And since I'm building this for a hexapod, I definitely want 14 millimeters. My entire design is literally it's 30 millimeters. So 14 millimeters will add a lot. I'm using 4 millimeter ball bearings. So I feel like what we can do with this design, how we can upgrade this design, potentially use smaller ball bearings, cut back on the cycloidal discs. Cycloidal discs is already it's a pretty strong disc drive system, pretty durable. Really don't feel that to be very necessary. The one thing I'm struggling with is how they're mounting this encoder, and how are they getting the output? Let's take a look on their video. Okay, so, oh, this one doesn't have an encoder mounted. To be honest, the 3 disc design is worth exploring. This could potentially. Actually, no, it's not really worth exploring, is it? I mean, what they're doing is basically making 3 different cycloidal discs, two being together in them. Or you can just make 2 cycloidal discs and make them big, like thicker. So I don't really see why you would need 4, to be honest. I feel like this overcomplicates things. Let me take a look at, and they're not using steel rods, which I feel like is a pretty big thing. We should use steel rods. And the reduction ratios might be too low for the power. I don't know. Mine is 35 right now. I could go from 35 to 30 or even 28, 27, somewhere around there. They are using ball bearings, which I don't know how. What are these type of bearings? This is 8 millimeter diameter. 8 millimeter diameter. Which one am I using? Mine is. Wait a second. Diameter 9 point. Assuming they used a generator, this should be. Oh wow, 8 point. That's strange. What size ball bearings am I using? Let me measure mine real quick. Yeah, mine is 8, so I don't understand how they're... Oh, oh, I see what they're doing. Oh wow, okay. This is another thing that could potentially be useful. Okay, so I'm seeing this is 3 millimeters. This right here is okay. This is pretty smart. I thought about doing this, but I wasn't sure how I can make the design like this. Because you can either choose this diameter or you can choose this one. I didn't know you can choose. Okay, so if you made this 3, then this right here is 8.2. Oh wait, this is 3, and this is 5. 3 and 5. I don't think this matches up. Wait. I don't think this is optimized design, right? Question mark? Unless I'm just completely stupid. Wait, I can try. Cycloidal drive. Okay, so the green thing is output disk pen. His was 3 because it was M3. Pen diameter. Oh wait, no, pen is, let's do 8. This to be 3. Okay, looking at this design. So if we go to solid measure, this is a diameter of 7. Oh wow, okay. And this is what? What is this? This is 3. And this is diameter 7. Yeah, I really don't understand how he's doing this. This is 5. And this is 3. Yeah, that's really strange. Is that optimized? Huh. That's quite strange. Hmm. That's a pretty cool thing. New thing to learn. Okay, let me check. Hole diameter is 3. This is 5 though. That's so weird. Does this make a difference? It shouldn't. Well, let's stick to... Now thinking about it, this design is actually a lot better. Yeah, I don't think this is optimized. Because if you look here, this bolt is literally inside of this thing. So this is definitely not a very... I don't think you can do this, to be honest. Wait. Yeah, you definitely can't do this, I think. Because, wait, look at the way it's mounted. If you look at the way it's mounted, this is... I'm sure these bolts are mounted correctly. 100% the bolts are mounted correctly. But we can see the bearings are also mounted correctly, but they overlap like this. So this is a flawed design in my opinion. So I don't think we should do this. Yeah, I don't think this will work. I think he just went ahead, did it, tested it, and it worked somehow magically, but there's probably some sort of friction and not very good backlash or something. I'm not sure. But the main thing you can take away from this design, I think, is the encoder on the inside. And obviously this motor, which... Can I copy this entire thing? Can't. Okay. Okay, so with my design, let's wait. Okay, I want to check how he is able to... Okay, what are these ball bearings? These are 27. 27? Wait, so it's 20 by 27 by 4? It is. Okay, this is very great. This is what I was going to buy. Okay. 20 by 27 by 4. Okay, yeah, these are the ones I was actually going to buy. And his design looks pretty nice. And he also uses these. But now thinking about it, maybe we shouldn't do that. Maybe we should. Maybe we should. Okay, there's a trade-off. If we did this, you gotta scrap this design. This is pretty compact. Actually, no, no, no. It'll be fine, right? Right? If we design this from scratch, Cycloidal drive. Okay, let's do a 30. And then we want this to be 70, 65 maybe. We did 50, so we're gonna have to do more. Ring pin diameter. This will be 3. Actually, it shouldn't be 30. It should be 2.9. Let me think. 2.93. The M3 dowel rods are always 2.9. I'll just do 3. This needs to be lower. Does 1 work? 1 does work. Wow. 1.1. Okay. The other parameters is... Okay, let's see here. Hole diameter. Output hole diameter. This is going to be 8. 8. We should do 8 pins to maximize torque. Actually, maybe we shouldn't do 8 pins. I feel like this is overkill from other designs. We should do 6. Let me think about this. I think 6 would do because, okay, for example, if we're running this configuration. Oh my, I'm so stupid. Now it generated. Great. Anyways, if I'm running this configuration, this should be using more than 8, 100%. 1, 2, 3, 1, 2, 3, 4, 5. What is this design? Yeah, this is a very not like symmetrical design. Yeah, I'm not really sure whether I don't know. This is kind of weird. Oh wait, never mind. They're just missing ball bearings in random places. Okay. Another thing is, how are they mounting? Okay, what is the wait, these ball bearings, we can get rid of that. Okay, so this one and this one is the output shaft. I'm assuming. Or am I wrong? Dude, how are they bro, what? How are they mounting the screw in here if this is all one piece? This is called an encoder plate. There's only one body. So I'm assuming this is the encoder. It's mounted directly above with a magnet. That should be the magnet, right? Encoder magnet, yep, okay. I don't know why they went so overkill with the design. Like, what is this design? Why did they do this? Oh, I see, I see. It's so they can screw this down. Okay, this is the advantage. Being able to screw this down. Think I need to copy this design. Okay, so we have an encoder. And then we have... Oh wow, this is... Dude, what is this? What type of... 3mm, 5mm? Oh, that's just a screw. Wait, how is the... Yeah, it's just holes, so how's it mounted? I'm so confused. Maybe they can screw it from this bottom up? I don't know. I really don't know how they're mounting this. Maybe they're having a nut or something on here? Anyways, okay, so... They mount the encoder on top of this. And... Wait a second. But isn't this thing spinning? Oh, okay, this is a very confusing... Am I stupid? Wait a second. No, no, no. This is all stationary. This is the only thing that's... Oh, okay, I see. Okay, I see. Why did my screen just turn off? Well, okay, anyways. So this is the only part that's rotating. Okay, I actually do kind of like this design, actually. I think I'm gonna copy some good things about this. Perhaps... Okay, let's see. This is 12. Wow, okay. Minus 5. There's this 12. Huh, okay. Okay, I'm trying to think, is there really an advantage to a 3-teeth system like this compared to a 2-teeth? I, oth- like if we made if we made the teeth 12 and 12, but they're not connected, like if we made 12 and 12 and have 2 discs instead of 3, I don't really think there's too much of a difference. I really don't think so, so let me see what's the overall 73. Okay, let's see how big that is. You know, visualize this. Okay, that's not terrible, right? Like, definitely think we could improve upon this design in some aspects. Okay. Ooh, actually, it will be even bigger because this part will be mounted and this part will also be mounted. Okay, so let's design our own. Alright, let's see here. We need to make as simple as possible. Cycloidal drive, protection ratio 30. Oh my goodness, okay. I'm trying to think. Is 30 good? Or is 30 too much? We can do 28. 28 should be good. Okay, yeah, let's just go ahead and try to speedrun this part. Because we've done it so many times anyways. Let's do 28. Maybe we should do 29. I think 28 is fine, actually. 65, okay, so let's see. To make this optimize, 65 should be fine. Ring pin diameter. Ring pin diameter is 3. Hole number 6. Wait, why is this? This should be, what was it, 37? No, 27. Right? 27, yep, okay. And I think on the insides, I'm going to be using either ZZ or open. Maybe open. No, actually, no, not open. Maybe ZZ. No, I don't think we need rubber sealed. I don't think we need RS. Maybe overkill, and it's also more like more bad. Yeah, this design looks pretty good. Need to go to 45. I feel like this being farther out could also help because of torque. Yeah, it should help. Should it? I don't know. I don't. Maybe I don't know. In my head, I feel like it would help. I'm not sure though. Okay, this looks pretty good. To be honest, I think we could even go 60. Perhaps. But this would need to be lower. And that's going to be not as torque worthy. I guess going 65 is fine. I don't know why my screen keeps shutting off. I want to also see from this point to this point is 1 millimeters exactly. That's pretty nice. It's only a 1 millimeter difference. This should be pretty good. Let's click create for now. I want this system to be pretty robust so we can go. Let's see here. Maybe we can do 8. That would make it very, very, very robust. And not very easily water jettable. But if we eventually get to water jetting these parts or whatever, could do something different. Do we even need to do 8? Like, seriously, like, we probably don't need 8. Let's stick to what we have, 5. Highlight everything. Unhighlight what we don't need. Oh my gosh, I just clicked out of it. Okay, wait. 3 millimeter dowel pins. 5 millimeter. 50 piece. 3x15. 20 piece. 50 piece. 3x25. Okay, this looks pretty promising. So we do have 25. Okay, so wait a minute, pause. I need to check something. The ball bearings, ball bearings, ball bearings. 3x4, okay, yeah. But each one of his is by 6, so the ball bearings don't even fit. There's 2 millimeters of clearance. Okay, so that would make it bigger. I feel like this design should be fine. I think 5 millimeter with 0.5 millimeters and 1 millimeter clearance on one side and 0.5 on both sides will be good enough. Okay, let's go with this part first. Just copy paste. 1 millimeter between. Why did I click OK? Set center. Wait, cancel for now. Create sketch. Sketch -1. Body. Click OK. Body 2. Do a move. Set their center. Here. Click OK. I'm gonna move this by the eccentricity time 2, which is -2. Alright. That's what my eccentricity was. Rotate this by. Oh shoot. What was my. Was it 28? I should probably check before I mess everything up. Wait. 28.1. Okay. Nice. Pause. What's happening here? You know, I'm gonna redo this part here. So. M. Okay. Oh, what's happening? Why is it being annoying? It's glitched. Okay, I think I fixed it. Okay, there we go. Nice. So -2. -2. Rotate this by 180. Divided by 28. Enter. Create sketch. -5. Open the sketch back up. Extrude -5. Join, no, new body. This new body here, click and move. Drag to center. Wait, that's not aligned. No. That's not aligned either. Great. I delete this. Delete. Move. Yo, where's the center? Is this the center? I think it's glitched again. Great. Nice. Let's close sketches. Move. Alright, where is the center chat? Why is it... Yo, it's actually glitched. Why is it... Yeah, I actually don't know what's happening. Oh, wait a second. I think I fixed it. What am I doing? Okay. We'll move this by a distance of -180 divided by 28. Okay, I'm gonna go do some calculations real quick before I go too far. Okay. Ooh, wait a minute. Okay, could it be possible I can set the reduction ratio based on a parameter? Is that possible? That'd be amazing. Wait. Let's do 30. Click OK. Okay, add-ins. Okay, can we do... Oh my... Wait, is this possible? It's not. Oh my goodness, okay. Okay, well. 5010 motor with 28 reduction torque. ChatGPT this part. Okay, so continuously it's 56 newton meters. Peak is this. Did they do... Okay, 5.6 newton meters is 56 kilogram per centimeters minus, let's say, let's do 1 newton meter off for the efficiency. We're gonna have what, 4 newton meters? It's 40 kilograms per. I mean, that should be strong enough. But also, the peak is 143 kilograms per centimeter, which is pretty strong. 14 newton meters. Okay, even if it's at like, say the gearbox, which I'm designing right now, is trash. It's like super trash. And it only gets like 70 or 80. Let's go with 80. I feel like 80 should be fine. 80% efficiency. Since I'm using steel pins and all that steel with ball bearings, it should be pretty high efficiency. So yeah, so 143 times 0.85 is going to be 121 peak power, and around 50 kilogram centimeters were 50 newton meters of continuous output, which should be strong enough. That's more than strong enough for this robot, I feel like. And there's gonna be 6 legs, so like, I don't know what I'm worrying about. 28 should be definitely more than enough, and it should also be pretty fast too. Okay, anyways, let's combine these two, I guess. Now that's combined. So this is 11. I'm trying to think. I feel like potentially this would not be strong enough, but I also feel like it should be strong enough. What we could do is actually this one. Wait, if we did this, this would be 6 millimeters, which should give us. Would this work? Let me think. You know what? Let's do it. Why not, right? This, we don't need this right now. So from here to here is what? Distance 13. Distance 13 if we're using 25. So let's see here. If we're using 25, 25 minus 13. So it's going to have 6 extruding out from both sides. 6 millimeters of these steel rods. New body. We need to have 1 millimeter down here. Extrude 1. Okay. So 6 sticking out both sides. Is that a good idea? Yeah, that should be fine. Let's do 6. And look at this side. Okay, I don't know why it's going on this side still. Let's just do -25. Join. There we go. Cycloidal disc, blah blah blah, blah blah blah. Okay, now it should be 6. Okay, so the other side should be 6 too. Yeah, it looks like 6. Okay. Now that we have this, let's make an output. We need a pretty strong output shaft. Carry all the load. Okay, let's see here. Edit sketch. We can just do, let me think here. Should we do 3 or 2? 2.8 maybe? Yeah, let's do 2.8. That should be fine. Okay, we need to pick up the pace a little bit. We're going kind of slow. Quantity 6, click OK. Should. How much do we need? To be honest, no idea. Let's go to this. It's probably too much. Okay, let me think here. Use 25. Is there 30 millimeters? Let's see. Where am I looking at? Orders and returns. Dude, where is my... Okay, there it is. Do they have 30 millimeters or no? What, you're joking me? You're joking. You're kidding. Oh, there is 30 millimeters. Oh, but it's only... What's the hex? Oh. There's only 10 pieces. 30 millimeters. 30 millimeters. We probably need to use 30 millimeters, to be honest. Do we? Probably don't. Probably just need 25. This is a grave decision, guys. 25 or 30? Why did it do that? This is 25. So it's gonna be 12 if we leave an extra millimeter. 12 if we can do 6 on both sides. Or we can do 10. Okay, 25 is good enough. So let's do this and this. And then I'll put this go away. Okay, how do I... No. Okay, extrude. Negative 4 maybe? Negative 25. Okay, if we did negative 4, that means we'll have 4 on the other side. 4 on the other side, 0.5, that's 3. We had... Okay, wait, let's bring back cycloidal disc. 9. 3. So it's gonna be 2.5. Keep this here too. Okay, let's see here. Oh my gosh, my head's hurting. Okay, I'm gonna take a look at their... Get rid of everything. I don't know how they made the entire cam as one piece, to be honest. This is pretty strange. Yo, what the heck is this? Why did they make everything one piece? This is a very strange design. This looks very complicated, in my opinion. Okay. I like what they did, though. They have the 3 and... Okay, I don't know what this middle hole is for, all the way through. And I'm not sure why there's this here. Maybe it's to add strength by parameters. That's probably what it is. Because I don't think they're putting a screw all the way through. Like, look, check under this magnet. Yeah, there's not a screw, so it's just for strength. Which I do like, actually. But I'm not sure why this bottom is so big. Yeah, I'm really not sure. But the thing also came with this right here. Maybe I could integrate this into the cam. Just like shove this in the cam or screw. Oh, I can screw this into the cam. That would be pretty useful in my opinion. Yeah, okay. Show. Let's do that. Let's make this visible for now. Okay. Construct, capture position, 0.5. Okay. Create sketch. From the middle to, okay, if we go right here, it's not gonna give us enough clearance. We did 53. It should be good. Join. What am I doing here? New body. This will be very, very strong. This side right here, like we've learned from all the other additions, that this side actually does not matter at all, to be honest. .5. Wait, what did I just do? Why did I do that? It's supposed to be 0.5. Okay, create sketch. What did I do? 50, 54, 53, 54. This one I did 53. This one I did 54. Doesn't really matter right now, we can change that later. Okay, 3, body. Okay, now, so from here to here is 25. This is perfect. And this will be very, very strong. And we can, oh wow, and this, we can add a space here for the encoder, I think, somehow. But for now, let's just go ahead and, where's the combine? Okay, there we go. Just keep this cut. And we can do keep tools. And then another one, combine. Don't keep tools. Wait a second. Why didn't this cut all the way through? Is my calculations off? Am I stupid or something? Hello? 0.5. How did I... This is 26. It is off. Wow, I'm so stupid. Okay, how did I... Thought I was right. Well, I mean, I guess I should just go... Get a 0.5. Get a 0.5. Okay, fixed it. Easy. Now that we have this, we need to do... I should want to delete this. This is kind of getting annoying. Should I use aluminum extrusions? It's a good question. Not sure yet. Still thinking. Still thinking. Okay. This shaft. I really hope there is some sort of 40, 47 by 4 ball bearing. Which I don't actually think they will sell this on Amazon. Yeah, there's always these ones, but I don't know. I don't really like this. What did this guy use? 50, 65, alright. I think this is too big. Okay, so by 47 by 4 ball bearings. I'm not sure why this is so hard to find. Is this not like a standard size or something? I mean, they make 30, 37 fours. I don't see why. Okay, like if I did 30x30. Yeah. These, they do make. Wait, maybe I look up standard size ball bearing. Okay. Okay, what is this? I'm so confused. Okay, so D and small d is. So they have 40. Big D is 80. Why? And where's C? B, C. They should be the same number. Yeah, okay. So 40. 18. Oh my god. Okay, yeah, this is not the size I want at all. Inner is. Okay, no. You know what? Definitely need to figure this thing out if they sell the bigger ball bearings without the annoying other stuff shenanigans. Oh, this is 53. Really hoping that. Wait a second. What if this was 50? We can put a ball bearing around here. Wait a minute. Chat, I might have an idea. Chat? No, actually, never mind. My idea won't work. Never mind. Okay. If we did what we were doing right now with this stuff I'm going with, it would be 37. No, not be 37, sorry. It'd be 30. Sure, 4.5. And this would be 37. Why did I do that again? 30. 1.5. Okay, if I have this and then a 27. Oh, wow. Oh, wow. That is definitely not going to work. We can't mount anything on this area. Alright, that's not very ideal. 40, 47 ball bearings. Okay, 40mm ball bearing. I'm going to text some people. 50 by 57 would, in my opinion, be the most ideal solution. So, one thing we need to get straight is that this old design is not going to work with the ball bearing that I have. So what we need to do is go with, this is going to be still relatively compact. Okay, and then, alright, so this will be the difficult part. Two of these. Since this piece is out of plastic, having 8.5 millimeters will really, really help the strength and rigidity of this overall design. Okay. I think what we need to do now is, okay, let's see here. If we did do 50, okay, 50 won't work. Change of plans. 50 will not work, chat. That's just great, because 50 goes beyond. 50 will not work because it goes beyond this. This is 45. We can't have. So we need to do 40. I think 40 works. Okay, apparently they don't really make 50 by 57 by 4 ball bearings. Well, okay then. As expected. Not a standard size. This will work, and it will work pretty nicely too. So 40. Actually, pause. 40 millimeter ball bearings. 40, 52 by 7. Alright, so that's going to increase our size quite a lot. Great. So we need 7.5. That's just amazing. It's nowhere near very compact anymore. 0.5. And where is our... And this will need to... So this will be the output. Right, let me think. Yeah. Should be the output, this should be the input. So we need a 180. Drag it down. It's gonna sit somewhere around here. So the overall size would be 61, and we also need to add a little bit more. It's gonna be 80. It's gonna be pretty thick, some pretty thick hexapod legs. Alright, let's make this disappear for now and focus on some other things, such as making the shaft. Alright, extrude, key position. Not extrude, I'm stupid. Create a sketch, capture position, -6, new body. Okay, from here. to here is 16. Oh, okay. It's a lot of useless space for nothing. Okay, extrude negative 16. New body. So this can go away. Go away. This can go away. This can go away. Extrude negative 4. No, wait, no, negative 6. I'm tripping. Okay. New body. This can go away. This can go away. Okay, ball bearings. I think we're just gonna stick with the 7mm thick one. It's gonna add a lot of weight, which I'm not very happy about, but it's gonna have to do for now. I mean, we can definitely make different iterations, but this is my first attempt at making a hexapod one. So 10 extrude. I mean, by no means is this the best possible design, right? So we can definitely optimize this some way or another. Okay. Okay, now that we have this. Okay, I really want to know how he's doing this right here. Oh, this is very... There's no way for this guy to mount this. I don't think this is a finished product, because there's no way... Okay, so the thing that's spinning is this. Okay, I want to isolate this. Just look at what this looks like. This would be pretty difficult to do without these being metal pins. This is pretty simple to do with 3D printing. But if I do want metal pins, this would be not a very great design for that use case. I really want the outer to be metal pins. But I did also see a different YouTube video. Cycloidal drive. I did see a guy make over here. I think I'm gonna copy this type of design. Okay, so he has one part attached this way. Okay, let's see how he's doing this. So essentially the bottom is attached this way. And then we have a big ball bearing. And then a middle shaft. Okay. They're 6.5mm. Should be good enough, right? Wait a second. His design is... How is he doing that part? I don't know. Okay, wait, let's make... From here, let's go ahead and do something real quick. Show all bodies. how can we make this work with our design? Okay, so this bottom piece right here is attached to the output. Yeah, that's right. Oh, wait, this is... Oh, wow. Okay, wait a second. This is very interesting. This is very, very interesting. Oh, wow. Okay. So in this case, both of these shafts will share the load equally, meaning that this part and this part should be, in theory, it would be most optimized to have this part and this part to be the same thickness. Oh my goodness. Okay, that's crazy. Oh, wow, okay. So in this case, what we need to do is, this is 8.5. This is 2.5. Pause. I'm gonna measure something. From here to here is 25. Okay, just to make sure. Now it's also 25. 5.5. 5.5. Great. Okay. This needs to be... Oh wow, wait a second. We don't even need this, do we? Okay, so this is going under, up, and it's attached to this output shaft. So, wait a minute. This is so hard to think about for me. I don't know why I'm so stupid. Oh my goodness, okay. So now that we have this taken care of, okay, let me think. So essentially, what's happening here is this part is his design. This part is extruding downwards. Oh, wait, I think I get it. Okay, so from here to here is 4.5. But if we did, okay, if we did a 4.5, we did another 3, this would be 7.5. And then we need to do a, say, extra 5 millimeters. Nice, okay, and an extra 5 millimeters to do, because of the arm. Now we can go like this and go, let's just go with 60 for now, and -5 and join. We don't need to do this. What am I thinking? Okay, let's go. This is actually a very, very interesting design, and I'm very, very like this. Very, very interesting. Okay. Oh wow, that looks stupid. Okay, let's go like so. Oh my gosh, I did it at the wrong spot. I'm so stupid. Okay, delete, delete. Why is it not? Oh, well, wait. 3-point arc. Uh, -5. Join. Okay. Okay, that's not good. We did it wrong. This needs to be like this. Okay, we'll delete this, I guess. Sure, -5. Join. Yep, this is looking pretty good. We can low-key just mirror this on the other side, so I don't know why. I don't know why it's not mirrored. I don't know why I did this part. Yeah, let's just take this body right here. I'm gonna go like this. Copy paste. Let's mirror this like this. So, and looks great. Is this 0.5 millimeters? 0.5 it is. Nice. Okay. Now that we have this design going on here, we can also work on the body. It depends. And then the pins should definitely have enough room here and here to mount it. Oh my gosh, this is coming out amazing. Okay. The body. Let's work on the body now. Show all bodies. Oh my gosh, I'm so happy. Okay. Here to here is 0 degrees. And this to this should be 0 degrees. Okay, this is awesome. So what we can do here is do a get rid of this, get rid of this. And we can just mirror on the other side. Oh my gosh, this is awesome. Okay. Okay, construct this plane 0.5. And then we can do a sketch. Start from the middle, that's correct. Let's go 75. I really hope this doesn't weigh a ton, because that would not be very ideal. Yeah, it's probably gonna weigh a ton, but it's okay. 6, 7. Okay, I'm going to do a new body and bring back all the other parts. Show all bodies. Okay, so I do definitely have a lot of room to go. I can go all the way up. Let's see here. So we got 6 more, so we can go 5. To be conservative, we can do 4. What did I just do? Okay, 4. This will leave us with 2 millimeters of space. Now that we have this done, we can isolate this part by itself, do a create sketch, and that's okay. What is the bearing? $40 by 52. Okay, so 40. So from the middle, we need to go 52. Screw this all the way through. Okay, now we can show bodies. Okay, this looks so good. Let's freaking go. One thing of concern here, this is 5.5. This is 7. So I actually did mess up here. Let's go 2. -2. -2. 2. 54. Okay, so my goodness, this is getting quite big. Let's keep going with the design. Let's not give up yet, guys. Even though it's getting quite ridiculously big for an actuator, but it has to be done. Unless I could find some thinner bearings or do some more optimization, which would be quite hard, but I'm sure we can figure it out. So let's do 2. Okay, let's see here. Make sure this is not touched, okay. Here to here is 7.5. What? Okay, that's more than enough. That's 2. 7.5. Let's go straight to the middle from here to here. 6.5. So we need to go 7. Let's get rid of this. Let's just go straight to 7. I mean, create sketch. Here looks pretty good. We'll have a little bit of clearance. Will that be enough? Actually, this part will be. This will be enough. So 7. And we will do a new body. And then we can combine this and this. Come on, combine. Hurry up. There we go. Perfect. And now we can do a. Let's get rid of this so it doesn't cut this part. Now we need to cut everything. How do I do this? What am I doing? Oh, okay, anyways. Just blinked for a second. This one. Okay, come on. Man, why is it not clicking? Oh my gosh, this is annoying. Cut. And guess we can just mirror this over. So copy paste. 180. Nice. That looks so good. Oh my goodness. Wait, pause. Before I do this. Actually, that's okay. Hit sketch. Okay. $180, that's fine. And I'll just go with arbitrary. Okay, we need to get rid of this for now. Join. Oh my gosh, look how look how massive that is. Okay. For now, let's just go with it. Create sketch. Project. No, project this. Why can't I project this part? Okay, there we go. Okay, I'll make this disappear. What was that? Like 20? There we go. Join. Alright. We have our robot actuator. Now let's bring in the motor. And secure the motor. Bro, this looks so freaking good. Holy crap. Okay, this is awesome. We might be slightly, just slightly oversized. 73. Oh my god. It's gonna at least be 80. Oh, it's gonna be over 80. Will it be? Probably not. Okay, let's see here. Okay, let's work on the center shaft now. Okay, where did that one go? Okay, actually, let's label everything. Let's put one. Yo, pause. What is this? This should not be there. Okay, I need to do not in use. Put one. Okay, there we go. This and this. This should work, right? Unless I'm like stupid and this. Like, imagine this design is just fundamentally wrong and I'm doing this completely wrong. But I think this is right. Should we have two? Is 2 millimeters of clearance good? And we can connect these two somehow. We'll work on that later. What am I saying? Okay, once I labeled everything. Body 1. Body 2. Alright, let's go work on the input shafts now. I mean the input shaft. So apparently this got deleted somehow. Wait a second. It got joined. The heck? That shouldn't have happened. Anyways, so from here to here is 20. It's just annoying because 20 millimeters of waste space basically. Oh well. -20. New body. When did it get joined? I don't even remember. Wait, what was... What did I just... Okay, strange. Okay, so what did I just hide? Okay. So this needs to go 7. Okay, nice. So we have this now, which is symmetric. Not in use. Body 1, body 2. Okay, now these are the shafts. And so they're 20 by 27. So let's go ahead and do that. Definitely don't need this. Great sketch. So the outside only needs to be 20. And this should be 27. Yep, okay. Actually, let's get rid of this and get rid of this, and then do extrude all the way through. And now we can bring back this and this. Wait, no. Hey, what's the other one? Is it this? Okay, yeah. Input middle 1. Input middle 2. Wait a minute. What is this? Oh, this is input top 1. Input middle 2. I'm gonna cover myself with a blanket. It's getting quite cold. It's quite chilly. Okay. And what is this? This is input bottom. Okay, now we have this done. Get rid of these two. Do an extrude. 20. Negative 40. Get rid of this. Bring this. Wait, no. What did I just do? Nothing. Great. Okay. Create sketch. 20. Negative 10. Input bottom. Body 1. Input top. Input middle. From here to here should be 1. So what we can do is extrude. Pause. I need to think about something else. Does this design work? That's a good question. I think it does. It should work. Right? Can we optimize this somehow? Yep, it's pretty optimized, in my opinion. I think we're fine. So 0.5. And then input middle. Come on, bro. Why is this struggling? Of 0.5. 0.5. 0.5. Nice, okay. So, there's a lot of dead space here in which we can add an encoder, which will be very, very useful. And I can just snatch it exactly straight from this guy's design. Where's the encoder? Where's the encoder? Encoder. Copy. And paste new. Okay. I think we should be able to fit this somehow. Also, let me just do a... His design is 70... Oh, how's this 73? That's literally shorter than mine. Dude, what? Yo, chat. Chat. Okay, this is not good. Let's see. Let's try to do something about this. His is 73. Oh wait, mine is 54. Plus the motor though. It's gonna be around the same size essentially. Okay, so mine is even bigger than his. But his is way, way more compact. Look at this shit. Okay, so I see, okay. The problem with mine and his is he doesn't have this much dead space here and here. Okay. Well, this is quite a disappointment. Diameter 82. My diameter is going to be what? Like, I think my diameter is slightly smaller than his. 82 is, yeah, my diameter is around the same size as his. But his is just so much more compact. And why is his so much more compact? How is he able to do this? But with this version, there's no way you can add a... Is there any way? I don't think there is. Is there? Question mark, that's the question. Is there a way to add steel pins? Wait a minute. This design isn't finished, I keep forgetting. Because he needs to add another arm here. And an arm here? So he needs... Okay, so yeah, our design is pretty similar. Keep going with my design. I had a heart attack for a bit. Okay. So we need to add this encoder somehow. Maybe we can just steal this part. Okay, let's see. We need an encoder magnet. Okay, wait. Okay, so maybe we can do... Okay, let's rotate this 180 to point the magnet on where it will be facing. Okay, if we face this down... Okay, I'm trying to think of, is there a way I can potentially... Oh, there is. There absolutely is, isn't there? Okay, let me do some measurements. From here to here is 23, so assuming this is a square. Assuming this is a square, what I can do is create sketch. We can go like this, 23. Wait a minute, what is wrong with this? There's something wrong here. Oh, I'm stupid. The sides of the... From here to here. Okay. I'm so stupid. Okay, anyways. How can I do this? How can I mount this? I want to mount this directly on top of this. In a way, wait a second. This is definitely possible. I just need to figure out how. Okay, let's make this go down. Oh, what? A tad bit. And then bring back the... Yeah, how's this perfectly aligned? Did I do this? Why is it perfectly aligned? Is it perfectly... It looks perfectly aligned. Oh well, okay. Anyways. Let's see. This is... Radius of 4, okay. So what we can do here is create a sketch. 23 by 23. And then -3. Okay, why is there a... Wait a minute, why is this not attached? Should this be attached or should it not be? Let me think. Would it be easy? Okay, you know what? Okay, let me think. If this isn't attached, this will all be supports when I print this. If I attach it. If I don't attach it, I could just attach some bolts to it. I should probably not keep it attached. Should probably do something more like this. Unless I can do a fillet here, which I can't because there's gonna be a ball bearing. Okay. Well, in this case, let's go ahead and do a... Okay, I need to also check how big this magnet diameter is. So it's going to be 5 millimeters. And how... 5 by 2, okay, nice. So what I can do here is go with a 5, go with a 10. This should be able to hold it perfectly. Maybe a 5. And go back to a sketch. Negative. Let's do -3 for now. Because, oh yeah, this is definitely more than enough. Okay. Yeah, I want to bury the entire encoder within this part, which will be pretty nice, pretty solid. Okay, now that we have this, let's make this go down by another -5. As long as this is 4, we should be fine. Okay, now that we have this, we can do a... Okay, let me think here. How do I do this? We don't... Okay, where's the encoder? I mean, now we can just lower it in there. Probably add some clearance. Probably do like 24. 24. Enter. This should be 24 too. This will be easier to deal with. Now we can just plop it down there. And how do I... Wait, this to this is... Okay, this is quite weird. 22.62. Is this accurate? 2.62. Is it maybe because it's going from here to here? Oh, okay, that's why. So it's 16. 22.627. So 22.267? Was that what it was? I don't remember. But there's no way I gotta print like 18 of these. That's crazy. What is this? Oh shoot. I'm sure using an M2 screw should be fine, right? Okay, how big are these holes? They are diameter 4. Should I use an M3 screw? Okay. Final parameters. M3I. 3.8. Comments. M3 heated insert. Okay. So we can do a M3I and do 4. And then we need to check if this is correct from here to here. 15.7. Okay, I apparently remember this number wrong somehow. Might be a little bit dumb or something, I don't know. I'm so off. What am I doing? .627. Okay. Alright, there we go. Now it should be good enough. Good enough. Okay. I think we'll have enough clearance to mount this. If we don't, that would not be very ideal. Well, the way he did it was he mounted on the back. Which I still haven't figured out how he did that, to be honest. Like, how did he do this? Like, this screw... Maybe I'm just too dumb to understand. Okay, this is 5mm. But, like, how, though? I mean, it would be best if I could just mount it straight on here. I'm not sure. Maybe we can do an offset by 2, 1.5 maybe? And then do a here. This is probably really stupid, but Wow, look at my ingenious design. That's probably really, really dumb. Okay, let's do this, 4, click OK. This is either really, really dumb or it might work. And before I do that, I need to check. Here to here is 4. Which is stupid because actually no, it would work. Okay, but first we need to get rid of this. Why did that disappear? What is happening? Oh. Well, we can cut it later if we need to. But let's go ahead and do -4. Okay, did not mean to do that. It was supposed to be join. Okay, there we go. Perfect. Totally. Okay. Now we can put threaded inserts, mount that, and then this will be a 2mm difference. Let's do 1. What did I just do? 1. And do 0.5 here. And then do a fillet of 4. And then the thing should be able to fit. Before we do that, I don't like how this is rounded. That looks stupid. So we should make it not rounded and make it look not so stupid. By doing some type of magic. Not that. Like this. Going here. And then going 24 by 24. And then clicking. Clicking what? What am I clicking? And going like this. And then clicking this. There we go. Okay, now that doesn't look as stupid, which is great. We can put the encoder here with the magnet. As long as the center shaft doesn't break, I think we will be pretty chill. Another thing is how... Wait, how can I... Okay. Okay, not that. Here to here is 12. So... Shit. Okay, how long is this? Here. Here. 43. We can just cut a 50mm one. That would work. Put it all the way through, which should probably give us the best results. Is there a way we can make this slightly smaller? Is there possibly a way? Okay, it should probably, this is kind of like literally inside of the thing, but I mean, okay, let's take this, let's take this -2. And let's do a create sketch. This piece right here will not be experiencing literally any torque. Let's go 12. Dude, I'm actually so happy. This is pretty promising. Okay, so this should be an M3 screw. And I can just do 2.8. Extrude both ways. Okay, M3 screw. Let's see what the size of the head is. We can just do 6 would be perfect. Okay, maybe 6 is not perfect. Let's do 5.5. 5.6. Center point. Okay, why is it? Extrude. Need to do 2 sides. This upside needs to go all the way up. And this downside here can go. Actually, this doesn't need to go far. We can just do 1. Mainly like this. This looks pretty nice. Now we can do a look at everything we made so far. Which looks stupid, but oh well. We will fix it. Bolts will go all the way through. Okay, let's think what can and can't be connected. Like always, these 2 pieces can be connected, so let's go ahead and do that. Join. This piece and these 2 pieces can't be connected. They added a hole all the way through, which is a good idea, which I think I'm going to do too. Actually, before I do that, let me think. Instead of adding a hole, we could add a rod. Adding a rod, a non-symmetrical rod all the way through could be a better idea instead of a hole. Maybe not. Maybe it's not a good idea. Maybe it's not necessary. We need the screws to go through, all the way through here, all the way at the bottom. I think this should be the overall design, right? 12.5. 12.5 times 2 is 25, so that everything works. It's gonna be quite heavy too. Now obviously add some little clearances here and there. Okay, let's get rid of this and take a look at this. This looks quite close, it's 0.5. Can we somehow reduce that to make it 1? Would that be necessary? To 5.5. Negative 0.5. Body 1. Okay, that's a pretty easy fix, so we can just go ahead and get 0.5. Here to here is 12. Oh, wow. Okay, we can just add a ginormous fillet here. Here. And literally make it look like this. And it would still have the same performance and it would be round, which looks pretty cool. Okay, anyway, so let's go ahead and 7.5, so let's go ahead and do a great sketch. Oh wait, why is the sketch here? The sketch should be here. Sketch. 0.5. Okay, actually, let's add this later. Actually, no, we should add it now. Does it matter? Probably not. I'll put one. No. Not in use. Okay, should this be in use? Let me think. For now, let's get rid of this. What would be easier? Output. Oh my goodness, that definitely need to be in use because I just thought of it. How am I supposed to put a ball bearing here with this and this being blocked off? I'm so not very smart today. Okay. Okay, that is a very good thing that I caught, or else it'd be very, very funny if I printed this entire thing out and then that happened. Okay, so let's actually just focus on copy paste. Here, and it should be 40 or 14, that's what I meant, yeah. Okay. Okay, let's see how we can mount the screws. So one side we'll use, I guess we can just use heated inserts. Yeah, we can just use heated inserts on one side, and should we do that or no? Let me think. Probably shouldn't use heated inserts. Should we use the lock nuts? Should we use the lock nuts though? I don't know. Heated inserts would probably be a better bet. Be simpler. This is only 5 though, the heat insert is 4, so that's not a good idea. Let's focus on the side we know how to do and do a chamfer. Okay, yeah, that's quite annoying. Negative 0.5 of 1.3. Okay, let's go like this. And just go ahead and add chamfers to everything first, and then we can worry about the other thing. Okay, and chamfer we can do 0.5. 5.8, that should be fine. Okay, if we did this, I'm thinking of just using normal nuts. Or just not using anything at all. I feel like normal nuts doesn't really provide any advantage at all over over than over being just screwed straight into the plastic. I feel like that would be more secure than using nuts. Like, what's the point of using nuts? Or I can use lock nuts. Lock nuts, though, I think it's 4 millimeters. That's leaving us only with 1 millimeter space to screw into, which isn't very ideal. Yeah, it's not very ideal in this case. I think I'm gonna keep it simple and just screw it straight into the plastic. That would keep a pretty good hold. And that should make everything very, very simple. What was it again? 40? What am I doing? How much does this need to be? 7? Does it need to be 7? 7.5? Okay, now we can go ahead and do a... Wait a minute. That doesn't seem right. Okay, never mind. Seems right. 42. Extrude 0.5. For the bearing to sit properly. And now we can do a... Now we can do a... What was I thinking? Oh yeah. Extrude. Create sketch, yes. Okay, go here. Here. -2. Join. Add a fillet to each of these. Fillet. .5 is good. Alright, nice. Yo, what the heck happened here? What the heck? Okay. Uh. Uh. This is not meant to be like this. I'm going to delete this. Unless there's another way. There's not. Okay, I'm just gonna go delete it. Make another one. Extrude -2. Why didn't it work? What? Oh yeah, join. I'll figure the fillets out later. I don't feel like doing it again. Okay. Now that we have this. Encoder here. Let's work on the... Wow, it's almost 2 hours. A few more seconds and it's 2 hours. It's still recording. Nice, okay. Let's work on the... You know what? We need to work on this part. Maybe we can just like copy paste this over, to be honest. Like, come on. I'm sure this guy won't mind. Right? Like, haha. Okay. So this needs to put output 1. Okay, this... Okay, how can we do this? Let's make this more clear about what we're doing here. Because, yes. Let's do a... Can we cut? How do I do that? I haven't done that so long. Where is it? Split face, split body. Body to split, splitting tool. Okay, let's do a create sketch, project, boom. Oh wait, no, projected wrong thing. Boom. Okay, perfect. Now we can get rid of this and split this here. Okay, how do I do this? Where is it again? Split body. Body to split, splitting tool. Split. Now this is no longer in use. No use. Okay. Nice. So we need to mount a few screws into this body using hopefully some sort of threaded insert or heated insert or something like that. Should be plenty strong. You know what, I'm gonna go ahead and add the fillet of 4 because I don't think that's gonna interfere with anything else. And we're gonna remove it later if we need to. I like to do fillets last, but in this case, it should be fine. Okay, now that we have this, we can also do this side. Can we copy it over? We can't because it's different. Okay, let's see here. Alright, let's do the same thing. Create sketch, project. Okay, done. And we can do a split body. Body split is this. Pause. Before we do that, let's get rid of this. Body to split is this one. Splitting tool is this. Okay. No use. Get rid of this. Okay, where's output? Where's the... So this is output 1. Output 2, I mean. Wait, this is output 2. What is this? This is also output 2. How can they both be output 2? Oh well, whatever, don't care. Anyways, now we need to go ahead and build the this part for the thing. Maybe I'll just copy and paste it, to be honest. What does this look like? Hopefully he doesn't get annoyed and be like, oh, you stole my design. Or whatever. Why is this not closed all the way? That's bothersome. Okay, that's very bothersome. Okay. Is 4 enough? Is 4 enough? 4 should be enough because we're putting M3. Is this M3 or M4? M3, 20 millimeters. Let's just do that then. I mean, how do I? Where is this? Find a browser. Whatever. Let's make my own. I don't know where it is. So we have the motor here. Let's bring back the bodies. The motor needs to be connected to this part right here. So create sketch. Why is this motor not centered? It's quite annoying. Okay. Let's go 60. -5. Join. Okay, how do I center this motor? Let me do a joint. Or not, I don't want to do a joint yet. Because I don't have any components yet. Okay. M sub joints. Okay, why is this all crooked? Like seriously, why is this crooked, man? I don't know why this is crooked. Maybe because this guy's design is crooked. It's not crooked, so why is mine crooked? I don't understand. Okay, there we go. Made it easy. Thanks for the design, buddy. Hope you don't mind. I gave you credit, okay? Chill. Wow, look at my amazing design. Okay. Uh, is it flush with the thing? Okay, let's do a joint. This to be joint with. Okay. What is the here to here? 3.5. What just happened? Where is my part? What? Okay, question mark. What am I doing? Lucky forgetting. Oh yeah, okay. Let's put this over here for now. Okay, we shouldn't do that. What we should do instead is this. No, we should do this instead. This being mounted to this. Okay, what the heck, man? Like, what? Seriously, the heck? Like, are you joking me? Okay, this entire motor needs to go to that. So I don't understand why it's just that one little thing. Usually it doesn't do that. Like, it shouldn't do that. Like, hello? Like, you know what? Scrap this design. Stupid. This is making me annoyed. We will get a new motor. I don't want this anymore. Let's get a new motor here. Okay. Copy. Paste new. Why can't I even paste new? You know what? I'm gonna copy this again. Copy. Paste new. Okay, please be centered and great. Look at that. It's not centered. I don't seriously do not understand why it's not centered. And I can't copy this for some reason, which is quite annoying. I don't know. This long, it's been this long, and I still don't know how to copy what is this called? A component? Wait, no, this is a component. Don't know how to copy this in there still. Okay, let's figure this out, guys. Insert component. Cycloidal drive. maybe it's this. I should probably save this. Probably a good idea to save this. Hexapod, Cycloidal, 5010. Wait, so did it work? Did it work or what? Oh, it did work. That's crazy. Oh wow, okay, nice. Guys, I figured it out. I figured out how to do it. Okay, so now we can just do M, and then we can do, we have to rotate it this way by 90, drag it down. It looks pretty centered, to be honest. Is this centered? Oh wow, that actually looks pretty centered. Move down. I don't think we need this piece. I don't think this is very nice. Oh wow, it's on the wrong side. Great. Move. Let's rotate 180. And move this up. Click OK. Don't need this piece here. Can match this straight to here. Let's do a chamfer. This could potentially be a weak point though, so we don't want to do that. Okay, how long are these screws that I have here? They're 50 millimeters? I think they're 50 millimeters. No, they're 72. Okay, yeah, I'm just gonna cut them down to size then. Anyways, so here. Okay, how do I... Oh, also, another thing, there's also to do a 5 negative. Probably do longer than -5. There's a little hole poking out. -10. Oh yeah, and also why is it okay? Create sketch. A 2 millimeter hole all the way through. Nice. Okay, this adds some more parameters for walls. Now that we have this, now we can mount the motor. Okay, let's do bodies, and now we can do a symbol. Not like that. Here to here. Revolve. So, why is it doing that? Okay, let's do it rigid for now. From here to here, how many? It's 23.5. Okay. Oh yeah, this, we should probably mount this too. I'd probably scoot it down a little bit. It looks good enough. Main thing is the motors. Okay, so why is this looking goofy? Oh yeah, it's the threads. I'm stupid. Here to here is 6. Okay, we're gonna go take a look at this. So this is 19. This is 16. Why did they do that? I don't know. Quite strange in my opinion, but oh well. Okay, so this is 50. Okay, why is this wonky, bro? Like, yo, seriously, why is this wonky? Is this like not straight or something? I'm confused. Zero degrees, so it should be straight. Not sure why it's not. Is it view? No, it's not the view either. No, that's annoying. Okay, I'm just gonna go with 50, and I'm sure going with 58 is more than enough. Okay, it's probably not more than enough. Let's delete the sketch. Okay, why can I delete it? Like, hello? Is it broken? It's glitched. It's glitched. Oh, click on it. Okay. So 7.5. It's like the same as the. Okay. Okay, sketch. $60 should be fine. Okay. Do M3. Should probably see what this guy did. 7.8. Why did he use 7.8? Okay. Use 8. Actually, no, we don't want to do this. This will look stupid. We want to do it at a 45-degree angle, in my opinion. 135. It's still recording. Oh my goodness. Okay. So 8. Okay. Change of plans. We want this to be bigger. $65. 8. This is to ensure that it doesn't rub against it. 8. Maybe we should do 5. Would that be a good idea? Or just do 4, like what he did. Let me think about this. Or we could do 6. Or 4. 4 is probably good enough. Okay, sketch. How should I mount this? What's the most bestest way to mount this? This looks pretty nice, to be honest. It's pretty professional. Maybe I can just copy this type of design. Probably will. 32. Let's go with a 19. And a 16. I still don't understand why it made the holes two different sizes. Okay, this needs to be 3 or 2.8. And we can just mirror this across. Don't even have a mirror line, never mind. Let's not bother with that then. 2.8. 2.8 is also always good for M3 because I can just drill it if I need it to be bigger. Okay. Let's go with... Okay, let me see what type of bolts are common. I'm guessing 5 is definitely common. Okay, let's see here. Let's see. Okay, so 5, 8, 10. Okay. 5 is probably good. We did a 5 here. I think we need to do a 6. So we can use a... Wait, this is 7.5. -1. 6.5. Probably just use a 3x6. Wait, what are the other? M3 screw. I feel like bolt nuts is a good idea. Yeah, we'll just go with 6 or 8. Extrude. 5.5. 5. You know what? Change my head. Change my mind. We're gonna do countersunk. 6.5. 8.5. Chamfer. 1.5. Alright, there we go. It's good enough. And why is that? Oh my gosh, why did I attach it? Okay, there we go. And this diameter is 25. Should probably add a little thing to keep it balanced. Not balanced, just we don't need to do that right now though. Create sketch. Okay, let's see what we can do here. We can do something like this, and this can go here, like so we can go like this. That looks pretty good. Yeah, let's do that. Let's go ahead and just... Okay, yeah, let's do this, and center point is here. Do 4, click enter. What? Why did it... Hello, why did it do that? 4. Okay, there we go. So 4.5. Okay, not negative 4.5. Oh my gosh, no, 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 not cut, man. Not cut. Okay, so join. There we go. And and combine. Okay, this should not be extruded from this. This needs to be separate. So what I can do here is I'm gonna drag this body out. I'm gonna drag it into here. Drag into here. Like so. Okay, never mind. Whatever, bro. Okay, when did I make this? Not here. Not here either. So here? Okay, there we go. Now we can join. This. Join. Okay, why did this one not join? Like what? I literally clicked it. Okay, why is it doing that? Like seriously, why is it doing that? That's so weird, okay. Okay, now, like, what? Bro, okay. So, we're gonna do a 3. Okay, nice. Nice, this looks really great. Okay, now we can just go like this. Definitely add a fillet here. Oh wow. Nice, that looks really good. And to reduce stress points, we can add fillets here, 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 here. Dude, hello? Why do I... Just do 10 is fine. about the other fillets later. Okay, let's look how massive this design is. 82. Alright. That's crazy. 82. Okay, that's not too bad. Each joint being 82. That's pretty bad. It's not that bad, but it's pretty bad. We definitely need to find a way to optimize, reduce the size potentially. Yeah, I'm sure we can figure something out. Also, 5mm 3D print might not be strong enough. That might be a failure point. I mean, to be honest, we could probably do down 1 more millimeter. I think it will work. But overall, I think this design should be pretty chill. No way, still recording. Oh my god, okay. Okay, so definitely I need to add some fillets everywhere. Add some chamfers instead of fillets, maybe, probably. Add some. What's that thing called? What is that thing called? Oh yeah, some clearance to everything. Oh yeah, wait. What am I doing? Definitely need to add some bolts here that connect down into this part here. Wait, no. What am I talking about? Bolts that connect down into this part here. This piece, I will just move down. It's flush for now. I want to get rid of this. Okay, so the thing about this is we definitely need to add a lot of threaded inserts. Each threaded insert is M3I. I think 8 should be good. And it could potentially be better if we add some M2 screws that just screw straight into the plastic to resist shear forces. Because I feel like shear forces could be a pretty major threat if the robot is dropped. -6. Definitely want to eliminate all possible failure points, so adding thread M2 would be pretty nice. Now that we have this, let's bring back, put 1. Okay, so this is a problem. This one. Okay, so maybe we need to offset this at an angle. Kind of forgot about this. So, finish sketch. Delete. Let's try this. Create sketch. 135. I think this will work, right? Unless, oh wait, no, this is the exact same thing. Yeah, I'm getting really stupid. Okay, not this, so we can do this instead. go like this. Now we can add this, and then we can do this to here. M3I. Enter. Okay, there we go. Please work. If it doesn't work, I'm gonna look so stupid. Okay, this will work. So -6. And we need to create another sketch. 2 point. We can just do 3. 2.9 to be conservative, okay? Center point here. Do 8. Boom, 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 boom. Select everything. And output 1, do an extrude. Cut. Nice. Alright, that looks amazing. Do the same thing with output 2. Yeah, I'm gonna do that later. I think this is it for tonight, guys. Thanks for watching. There's no way anybody watch all the way. There's obviously a lot of parts that needs to be improved, such as... Yeah, I don't even want to talk about. There's so many parts that needs to be improved. It's okay. I will finish the rest later. The fine details.